Imagine standing at the edge of a world that is quietly slipping away, not with noise or warning, but with a silence so deep it almost feels intentional. It is 12,800 years ago, and the planet is finally beginning to breathe again after ages of ice. Glaciers that once ruled the land are retreating, and life is returning in ways no one fully understands. Across vast plains, animals move in numbers beyond imagination. Mammoths carve paths through frozen grasslands, while giant sloths rise slowly to reach branches. Predators watch from a distance, measuring every movement with patience older than memory. And somewhere within this living system, humans are learning how to survive and adapt. The world feels balanced in a fragile way. Every movement has a rhythm, and every season follows a pattern that has lasted for thousands of years. Nothing suggests that this balance is about to collapse. Nothing hints that an entire era is approaching its final moments. Then something changes. Not slowly, not gradually, but with a force that breaks the pattern itself. The warming stops and the air grows sharp again, as if winter has returned to claim what it lost. Temperatures begin to fall, and landscapes shift in ways no one has seen before. What makes this moment so unsettling is not just the change, it is the speed of it. Within a single lifetime, the world begins to feel unfamiliar. The rules that once governed survival no longer apply in the same way. Animals that once thrived begin to struggle. Migration routes become uncertain and food sources disappear without warning. The vast herds that once filled the horizon grow smaller and more scattered, and the silence that follows feels heavier with each passing season. No one knows why this is happening. There are no explanations, only observations and fear. The sky offers no answers and the land no longer behaves as it once did. Everything feels as if it is shifting beneath unseen forces. If you were standing there, you would feel it before you understood it. A quiet sense that something fundamental has broken, that the world you knew is no longer stable, and that whatever comes next will not resemble what came before. This is where the story begins, not with certainty, but with questions that remain unanswered even today. Because what happened 12,800 years ago is still debated, still studied, and still surrounded by mystery. Scientists would later give this moment a name. They would call it the Younger Dryas. A period where the warming world suddenly turned back toward cold, a reversal so abrupt it challenges everything we think we know about climate. For over 1,000 years, the cold would hold its grip. Not for a season, not for a generation, but for centuries. Landscapes would transform, ecosystems would collapse, and entire species would vanish from existence. To understand this, you have to imagine scale, not just time, but change unfolding across continents. Rivers, freezing forests retreating, and ice pushing forward once more. A system that was healing suddenly thrown back into crisis. And yet the cause remains uncertain. Some believe it came from above. Others believe it rose from within the earth itself. And some suggest that multiple forces aligned at once. The evidence is scattered across the planet, hidden in ice cores, sediment layers, and ancient bones. Tiny traces of something unusual appearing at the exact moment everything changed. Clues that refuse to form a single clear answer. There are signs of fire across entire regions, layers of dark soil filled with remnants of burned landscapes, particles that suggest extreme heat far beyond ordinary wildfires, as if something ignited the land all at once. There are also traces of metals rarely found on the surface, elements that are more common in space than on Earth, appearing suddenly in layers of time that mark this exact transition, suggesting the possibility of something extraterrestrial. At the same time, there is another story hidden in water. Massive glacial lakes held back by walls of ice, growing larger as the planet warmed, holding volumes of water beyond anything seen today. These lakes were never stable. They were temporary structures built from melting ice, cracked and weakened by pressure from within, waiting for a moment when they could no longer hold. If one of these natural dams failed, the release would not be gradual. It would be sudden, violent, and overwhelming. A flood capable of reshaping entire regions in days. If that water reached the oceans, it could disrupt currents that regulate climate, changing temperature patterns across the northern hemisphere, triggering a cascade of environmental consequences. This is the alternative explanation. Not fire from the sky, but water from the earth. a shift in ocean circulation strong enough to alter global climate, a silent mechanism with devastating results. And then there is a third possibility, one that is more uncomfortable than the others, that humans themselves played a role, not as the cause, but as part of a larger system under stress. As humans spread across new lands, they encountered animals that had never seen them before, creatures that did not recognize them as predators. And that lack of fear may have come at a cost. Hunting pressures, even if small at first, could have pushed vulnerable populations further toward collapse, especially in a world already changing rapidly, where survival was becoming more difficult each year. The truth may not belong to a single explanation. It may exist somewhere between them, a combination of forces interacting in ways we still struggle to understand, each adding pressure until the system could no longer hold. What we do know is what came after, the disappearance of giants that once dominated the land, the silence left behind where herds once moved freely, and the beginning of a new ecological balance. The world did not end, but it changed in ways that would shape everything that followed. The absence of those massive creatures altered landscapes permanently, allowing new systems to emerge in their place. Humans adapted as they always do, changing tools, strategies, and movement patterns, learning to survive in a world that no longer offered the same resources, becoming more flexible, more innovative, more resilient. Cultures shifted and diversified. What was once a unified approach became regional variations, different groups responding to different environments, each finding their own way through uncertainty. And in another part of the world, a different transformation was beginning. Communities experimenting with staying in one place, learning to gather and manage plants in new ways. When the cold finally ended, these small changes would lead to something larger, the beginnings of agriculture, a shift that would eventually reshape human civilization. All of this traces back to that moment, that sudden break in the natural order, when the world cooled unexpectedly and forced life to adapt or disappear. Even now, we are still trying to understand it, piecing together fragments of evidence from across the planet, testing theories, questioning assumptions, searching for a clear answer that may not exist. Because some events in history are not simple. They do not have a single cause or a clean explanation. They are the result of many factors aligning at once, creating outcomes that feel almost inevitable in hindsight. The Younger Dryas is one of those moments, a point where climate ecosystems and human history intersect. A reminder that the world is more dynamic than it appears, and more fragile than we often realize. As you think about this ancient shift, you begin to see a pattern that extends beyond the past, a system capable of rapid change, sensitive to forces both large and small. The story is not just about what happened then. It is about how systems behave under pressure, how stability can give way to sudden transformation, and how life responds when conditions shift. And maybe that is why this mystery still matters, not because of the exact cause, but because of what it reveals about the nature of the world and our place within it. You do not need to choose a single explanation. You can hold all possibilities at once. Let them exist side by side, like layers in the earth waiting to be understood. Because in the end, the question is not just what caused the change, but how everything adapted afterward, and how those adaptations shaped the world we live in today. The ice retreated again, the climate stabilized, and a new era began, one that would eventually lead to us. But the memory of that disruption remains, hidden in data and preserved in the landscape, a quiet reminder of a time when everything changed, and no one fully understood why. As the story fades, you can imagine that world one last time. The cold air, the vast plains, the distant movement of animals, and the uncertainty that filled every moment. Then let it drift away, like footprints erased by time, leaving only questions behind. Questions that continue to echo across thousands of years. Far to the north, the ice still dominates the horizon, walls of frozen mass stretching beyond sight, their surfaces cracked with deep blue fractures that echo in the silence. Each sound a reminder that the structure is slowly weakening. Beneath that ice pressure is building. Water trapped in hidden channels begins to move, carving tunnels through darkness where no light has ever reached. Quiet systems forming that no one can see from the surface. At the edges, the melt accelerates. Summer warmth lingers longer than it once did. Rivers swell with sediment, turning the land into shifting pathways. Nothing remains fixed for long. In some places, entire sections of ice collapse, huge fragments breaking away and crashing into meltwater lakes. Waves ripple outward, carrying debris across wide distances, reshaping the terrain in ways that cannot be reversed. Further south, vegetation begins to change. Grasses replace older plant systems. Then shrubs begin to appear where open land once dominated. Each shift subtle at first, but impossible to ignore over time. Animals respond instinctively. Herds alter their routes, searching for reliable food. Predators follow, adjusting their strategies with each movement. Balance begins to feel less predictable. Some regions grow richer for a brief moment, an explosion of plant life during warmer seasons. But the growth is uneven and temporary, followed by sudden scarcity that disrupts everything. Water sources shift without warning. Rivers that once flowed steadily begin to change direction. Lakes expand and shrink unpredictably, forcing life to constantly adapt. In colder zones, survival becomes harder. Snow remains longer into the year. Short growing seasons reduce available food, and pressure increases across entire populations. Small changes begin to stack together, not dramatic on their own, but significant when combined. Each season adds another layer of difficulty, until the system begins to strain. Human groups notice these patterns, tracking not just animals but environmental signals, reading subtle signs in the land and sky, trying to predict what comes next. Tools evolve in response, not all at once but gradually. Shapes refine, materials shift, and techniques improve. Each adjustment driven by necessity. Communication becomes more important. Knowledge passed carefully between generations. What worked before may no longer be enough, and new strategies must be tested. Movement patterns expand. Groups travel further, covering larger territories, searching for stability in a world that offers less of it, leaving behind areas that can no longer sustain them. In some places, cooperation increases, multiple groups intersecting more frequently, sharing resources or avoiding conflict depending on conditions. Social dynamics becoming more complex. Elsewhere, isolation grows. Regions cut off by changing landscapes. Populations separated by rivers, ice, or shifting terrain, each developing in different directions. The environment continues to fluctuate, not returning to its previous state, but moving through phases that feel unstable. A system searching for a new equilibrium. Animals begin to show signs of stress. Reduced numbers in areas once densely populated. Younger individuals struggling to survive. And older patterns no longer holding. Predators face new challenges. Less prey means increased competition. Riskier hunts become more common. Energy spent without guaranteed success. Some species attempt to adapt, altering diets or behavior, expanding into unfamiliar territories. But not all can adjust fast enough. The landscape itself records these changes. Layers of soil shifting in composition, organic material building in some areas, while erosion strips others down to bare ground. Wind patterns alter gradually, carrying fine particles across vast distances, depositing them in new regions, changing soil structure over time. Fire begins to play a different role, not just isolated events but broader occurrences, driven by drier conditions in certain areas, leaving marks that remain long after. Ash settles into the ground, mixing with sediment layers, creating distinct boundaries that tell a story, even if the cause is still uncertain. In colder regions, ice continues its slow movement, grinding against the land beneath, shaping valleys and ridges over centuries, leaving scars that outlast the event itself. Ocean systems begin to react. Surface temperatures shift subtly. Currents adjust their flow patterns, a response that takes time to fully develop. Salinity levels change in key regions, freshwater mixing with saltwater, altering density and movement in deep currents, impacting climate far beyond the source. These changes do not remain isolated. They ripple outward through connected systems, a shift in one region influencing another, creating a chain reaction across the planet. The atmosphere responds in turn. Wind circulation patterns begin to shift. Storm systems behave differently, bringing unpredictability to seasonal cycles. Cloud formation varies across regions, some areas receiving less rainfall, others experiencing sudden increases, adding another layer of instability. Temperature fluctuations continue, not steady but oscillating. Periods of relative calm followed by sharp changes, keeping the system in constant motion. Human groups adapt continuously. No single strategy remains effective for long. Flexibility becomes the key to survival, and rigidity leads to failure. Shelters evolve with conditions, structures adjusted for insulation or mobility, depending on the environment they face, each design reflecting immediate needs. Clothing improves over time, materials selected for warmth and durability. Crafting techniques refined through repetition, providing better protection against harsh conditions. Food storage becomes more critical, planning for periods of scarcity, developing methods to preserve what is available, extending survival through difficult seasons. Knowledge of territory deepens, every detail becoming valuable. Locations of water shelter and food sources memorized, creating mental maps of survival. Despite all efforts, uncertainty remains. No pattern stays consistent long enough to rely on it completely, forcing constant vigilance. Generations grow up within this instability, knowing no fixed version of the world, only a landscape that shifts and challenges them, shaping their understanding of survival. Over time, certain regions stabilize slightly, offering temporary refuge, areas where conditions are less extreme, becoming centers of activity. These regions attract both animals and humans, creating zones of increased interaction, competition and cooperation occurring simultaneously, driven by shared necessity. But even these refugees are not permanent. Conditions continue to evolve, and what is stable today may not remain so. For long periods, across the planet, the transformation continues, not as a single event, but as a sequence of interconnected changes unfolding over time, each influencing the next. The result is a world in transition, neither fully old nor entirely new, caught between states that refuse to settle, and forcing life to adjust at every step. In the far distance, horizons begin to feel emptier, not because the land has changed shape, but because the movement that once filled it has faded. The rhythm of life becoming quieter with each passing generation. Tracks that once crossed the ground in endless patterns start to appear less frequently. Paths once carved by repeated migrations begin to disappear, slowly erased by wind and time. The silence is not immediate. It grows gradually, almost unnoticed at first. A missing herd here, a delayed migration there, until absence becomes the dominant pattern. Plants begin to respond to this absence. Areas once kept open by constant grazing begin to thicken. Shrubs expand into spaces that were once cleared, changing the structure of the landscape. This shift alters everything that depends on it. Small animals adjust to new cover and new risks. Predators must learn different strategies. The entire system reorganizing itself. Soil composition changes as well, without large animals moving across it, compacting it, mixing it, distributing nutrients. Growth patterns begin to shift in subtle ways. Insects follow these changes closely, populations rising or falling depending on vegetation, creating new balances that ripple upward, affecting birds and other small predators. Water systems reflect the transformation. Wetlands expand in some areas, while others dry out without constant disturbance, creating new patterns across the land. Seasonal cycles begin to feel different, not just in temperature, but in timing. Events that once aligned no longer do, disrupting long-established ecological relationships. Some species attempt to fill the gaps, expanding into roles left behind. But the scale is not the same, and the system remains altered. Human groups notice the difference. Less competition for certain resources, but also fewer opportunities of another kind, forcing adjustments in how they move and survive. Hunting strategies diversify, no longer focused on a few large targets, but spread across many smaller ones, requiring more effort and coordination. Time spent gathering increases, plants becoming a more reliable source of sustenance. Knowledge of seasonal growth becomes critical, as predictability in hunting declines. Communities begin to settle slightly longer in certain areas, not permanently, but with increasing familiarity, returning to the same locations repeatedly, building a deeper connection to place. Tools reflect this change clearly. Designs become more varied, adapted for different tasks rather than one primary function, showing a shift in priorities. Stonework becomes more specialized, shapes refined for precision rather than power. indicating a different relationship with the environment, one that values efficiency over scale. Fire usage evolves as well, not only for warmth and cooking, but for managing landscapes deliberately. Encouraging growth of certain plants, this interaction begins to shape ecosystems actively, small interventions leading to larger outcomes, gradually altering how environments develop. In ways that persist over time, movement patterns stabilize in some regions, routes becoming more defined again, but within a changed landscape. With different resources and challenges, social structures adapt alongside these changes. Cooperation becomes more essential, information shared more carefully. As survival depends on collective knowledge, generational learning deepens, stories carrying practical information, embedded within memory and tradition, guiding future decisions. Meanwhile, the climate continues its fluctuations, though less abrupt than before, still unpredictable in subtle ways. Maintaining a sense of uncertainty, ocean systems slowly regain stability, currents adjusting back toward previous patterns, heat distribution becoming more balanced, influencing global conditions once more. Ice begins to retreat again, more steadily this time, though still leaving behind marks of its previous advance. Reshaping coastlines and valleys, sea levels rise gradually, transforming coastal regions, submerging old landscapes, and creating new boundaries. Human groups adapt to these changes as well, moving inland or adjusting to new shorelines, developing strategies for unfamiliar environments. Continuing the pattern of flexibility, vegetation expands into newly available areas, forests spreading where open land once dominated, creating new ecosystems with different dynamics, supporting new forms of life. Animal populations stabilize in different configurations, smaller species becoming more dominant, filling niches left vacant, establishing a new ecological balance. Predator populations adjust accordingly, focusing on available prey, adapting hunting methods to match the new environment. The world begins to feel more stable again, not as it was before, but in a new form that allows life to continue. Human cultures reflect this transition, developing distinct regional identities based on environment and available resources, creating diversity across the landscape. Technological innovation continues steadily, driven by necessity and observation, each improvement building on previous knowledge, expanding possibilities over time. In some regions, experimentation increases, new approaches to food gathering, early attempts at controlling plant growth, setting the stage for future developments. These small changes accumulate over generations rather than moments, gradually transforming how humans interact with the world, leading toward entirely new systems. At the same time, memory of the past remains, not in written form but in shared understanding, a sense that the world can change suddenly, and that stability is never guaranteed. This awareness shapes behavior, encouraging adaptability over reliance, preparation over assumption, and observation over certainty. Across the planet, similar patterns unfold, different details but comparable processes. Life adjusting to shifting conditions, finding ways to persist. The transformation is not a single event, but a prolonged transition, spanning centuries of gradual adjustment. Following an abrupt disruption, each layer of change builds upon the last, creating a complex history, recorded in land, water, and living systems, waiting to be interpreted. And even as stability returns, the system retains its sensitivity, capable of responding quickly to new pressures. The world that emerges is familiar yet altered, a continuation rather than a replacement, shaped by what was lost and by how life responded to that loss. From this point forward, human influence begins to grow more visible, not as dominance yet, but as a consistent presence. Interactions with the environment become more deliberate, less reactive and more intentional, setting in motion patterns that will continue far into the future. What began as survival gradually becomes transformation, a shift from adapting to shaping, though still limited in scale. And beneath it all, the memory of change remains, embedded in systems that have experienced disruption, carrying forward into what comes next. Over long stretches of time, the land begins to smooth its scars. Channels carved by sudden floods soften at the edges. Sediment settles into quiet layers at the bottoms of lakes. Recording each season without interruption, These layers hold subtle variations, grains of different sizes settling at different rates, tiny fragments of plants trapped within them, creating a silent archive of change. In colder regions, remnants of ice remain, not as dominant as before but still present, lingering in high elevations and shaded valleys, slowly releasing water into surrounding systems. Rivers become more stable in their paths, carving deeper channels instead of shifting constantly, allowing ecosystems along their banks to develop, supporting more consistent patterns of life. Wetlands form in low areas, collecting water that no longer drains rapidly, creating environments rich in diversity. Where new interactions begin to take shape, plant communities grow more complex, different species layering over one another, competing and cooperating within shared space, establishing a structure that supports long-term stability. Trees begin to dominate certain landscapes, extending their roots deep into the soil, holding it in place and reducing erosion, transforming open areas into forested regions. This transition changes how energy flows, sunlight filtered through leaves instead of striking ground directly, altering temperature and moisture levels, creating new microenvironments beneath the canopy. Animals adapt to these forested conditions, some thriving in dense cover, others retreating to open spaces where available, leading to a redistribution of populations. Bird species expand in number and variety, taking advantage of new nesting opportunities, filling the air with movement and sound, adding another layer to the ecosystem. Small mammals become more prominent, occupying niches left behind by larger species, reproducing quickly and adapting easily, contributing to the changing balance. Predators shift focus accordingly, tracking smaller prey through different terrains, developing new hunting patterns. Aligned with the transformed landscape, human groups continue to adjust, spending more time in certain regions, developing familiarity with seasonal cycles, and recognizing patterns that repeat. Paths become more defined through repeated use, trails forming between important locations, connecting water sources, food areas, and shelter, creating a network across the land. These routes begin to shape movement, guiding travel and interaction, influencing where groups meet or avoid each other, establishing early forms of territory. Knowledge of plants becomes more detailed, understanding not just what can be eaten, but when it grows and how it changes, allowing for better planning. Certain areas are revisited regularly, chosen for their reliability, providing consistent resources, reducing uncertainty and survival. Over time, this familiarity leads to longer stays, temporary camps becoming more structured, simple shelters improving in design, reflecting increased stability. Fire becomes a central element, maintained continuously rather than recreated each time, used to alter surroundings intentionally, encouraging desired plant growth. These practices begin to influence ecosystems, subtly at first but with lasting effects. Human presence becoming part of natural processes, rather than separate from them. Water sources are observed more closely, seasonal changes tracked carefully, predicting when levels rise or fall, helping guide movement decisions. Weather patterns become better understood. Cloud formations, wind direction, temperature shifts, all interpreted as signals, reducing unpredictability over time. Despite increased knowledge, uncertainty remains. No system is completely stable. Unexpected changes still occur, requiring constant awareness. Generations inherit this understanding, building upon what came before, refining techniques and strategies. Through shared experience, social bonds strengthen within groups, cooperation becoming essential for success, tasks divided based on skill and knowledge, creating efficiency in daily life. Communication evolves alongside these changes, information conveyed more precisely, ensuring important knowledge is preserved. Across time, interactions between groups vary, sometimes cooperative, sometimes competitive, depending on resource availability and environmental conditions. Exchange of materials begins to occur, objects moving across distances, indicating connection between different regions. Even without permanent contact, stone materials from distant sources appear, showing movement or trade, suggesting networks forming gradually, linking communities over space. These connections influence development, ideas and techniques spreading slowly, adapting as they move through different environments, creating variation. In some regions, experimentation increases, trying new methods of gathering and preparing food, observing results over time, refining approaches. Certain plants receive more attention, not just collected but observed closely, understanding their cycles, leading to early forms of management. This does not happen everywhere, only in specific conditions, where environment and knowledge align, allowing new behaviors to emerge. Elsewhere, life continues as before, with mobility remaining essential, following seasonal resources. Maintaining flexibility, the planet continues its gradual warming trend, though punctuated by smaller fluctuations, creating a dynamic but more stable system. Compared to earlier extremes, ice continues to retreat overall, exposing new land over long periods, allowing ecosystems to expand into these areas, extending the reach of life. Coastlines shift with rising sea levels, transforming landscapes slowly, submerging older regions and creating new ones. Human groups respond accordingly, adjusting movement patterns, exploring newly available areas, while abandoning others. Over time, this exploration builds knowledge, expanding understanding of the world, mapping it mentally through experience. Rather than fixed boundaries, the memory of sudden change persists, even as conditions stabilize, influencing behavior and decision-making. Encouraging caution. This awareness becomes part of culture, passed down through stories. Not as exact records, but as guiding principles. Adaptation remains central, not as a response to crisis, but as a continuous process. Embedded in daily life, across continents similar developments occur. Different details but shared patterns. Life reorganizing after disruption, finding new forms of balance. The absence of former giants remains noticeable, not in every moment, but in the structure of ecosystems, shaped by what is no longer present. This absence allows new relationships to form between species and environments, creating systems that did not exist before, defined by current conditions. The world continues forward, carrying the imprint of what happened, not visible in a single place, but present everywhere. Each layer of time adds to this imprint, building a complex history that can be read only through careful study. Across many fields, and even as stability increases, the potential for change remains, embedded within the system itself, waiting for new conditions. Life continues to adapt, not reaching a final state, but constantly adjusting to what the environment presents. The patterns established now will influence what comes next, extending far beyond this period into future transformations. Across deeper time, the evidence continues to accumulate, not in obvious ways, but in fragments scattered through the earth. Each location preserving a small part of a much larger story, waiting to be connected through careful observation. Sediment cores from distant lakes reveal matching sequences. Thin layers aligned across regions thousands of kilometers apart, indicating that whatever occurred was not isolated, but part of a broader planetary shift. These layers differ in composition, some darker, richer in organic material, others lighter, carrying traces of mineral influx, each variation reflecting environmental conditions at the time. Microscopic analysis reveals further detail, pollen grains preserved within each layer, showing which plants dominated during specific periods, allowing reconstruction of entire ecosystems. From these records, patterns begin to emerge. Warm-adapted species declining abruptly, cold-tolerant species expanding into new regions, confirming the sudden nature of the transition. Ice cores provide an even sharper picture, layer upon layer of frozen precipitation, each year captured with remarkable precision, creating a continuous timeline of atmospheric conditions. Within these cores, chemical signatures shift dramatically, ratios of isotopes changing in ways that indicate temperature drops, trapped air bubbles preserving ancient atmospheres, offering direct insight into past climate. The transition into colder conditions appears clearly, not gradual, but compressed within a narrow range, suggesting rapid change rather than slow progression, supporting the idea of an abrupt shift. In ocean sediments, similar signals appear, microfossils reflecting changes in water temperature, species composition shifting in response to altered currents, indicating a reorganization of marine systems. Salinity markers provide additional clues, showing dilution of ocean waters in key regions, consistent with large influxes of fresh water, aligning with theories of glacial lake release. Geological formations on land support this interpretation. Channels carved by immense flows of water, deposits of sand and gravel laid down rapidly, indicating sudden high-energy events. These formations stretch across wide areas, not confined to a single location, but repeated in patterns that suggest multiple occurrences, rather than a single isolated flood. At the same time, other anomalies persist. Materials found in certain layers that resist simple explanation, their origins still debated, adding complexity to the overall picture. Some of these materials appear under high magnification, structures formed under extreme conditions, but not exclusively linked to a single cause. Leaving room for interpretation, laboratory analysis continues to refine these observations, improving accuracy and reducing uncertainty, allowing comparisons between different sites, strengthening or challenging existing theories. Dating techniques become increasingly precise, narrowing timeframes for key events, helping determine sequence and correlation across distant regions. Radiocarbon data aligns more closely over time, reducing discrepancies between samples, creating a more coherent timeline of environmental change. Optical methods add further detail, determining when sediments were last exposed to light, providing independent confirmation of dates, enhancing confidence in results. Climate models incorporate this data, simulating possible scenarios, testing how different factors interact. Under varying conditions, some models reproduce rapid cooling effectively, using freshwater input as a primary driver, demonstrating how ocean circulation can shift under specific thresholds. Other models explore alternative triggers, including atmospheric changes or external disturbances, examining their potential impact on global systems without requiring a single dominant cause. Results vary depending on assumptions, highlighting the complexity of the system. No single model captures all aspects perfectly, indicating multiple interacting factors. Field research continues to expand. New sites discovered and analyzed, providing additional data points. To refine understanding, older samples are revisited with new techniques, revealing details previously undetectable, sometimes confirming earlier findings, sometimes challenging them. Scientific discussion remains active, different interpretations presented and debated, each supported by evidence, yet none fully conclusive. Consensus builds slowly, not through agreement on a single explanation, but through recognition of complexity and the limitations of available data. The focus shifts from identifying one cause to understanding interactions between factors, climate, water, ecosystems, and human activity, all contributing in different ways. This approach allows for more flexible interpretation, accommodating variation across regions, recognizing that events may not have been uniform in timing or intensity. Regional studies reveal important differences, some areas experiencing more severe changes, others showing milder transitions, reflecting local conditions. These differences complicate global explanations, suggesting that a single mechanism may not account for all observations across the entire planet. Interdisciplinary research becomes essential, combining geology, climatology, archaeology, and biology to build a more complete picture from multiple perspectives. Each discipline contributes unique insights, but also introduces its own uncertainties, requiring careful integration. To avoid misinterpretation, technological advancements continue to improve capabilities, allowing deeper analysis at smaller scales, revealing patterns previously hidden. Within complex datasets, data storage and sharing increase accessibility. Researchers collaborating across continents, comparing findings and refining conclusions. Through collective effort, the process remains ongoing, with new discoveries regularly emerging, altering previous assumptions and opening new questions. Some findings support existing theories, strengthening confidence in certain mechanisms, while others introduce contradictions, requiring re-evaluation. This dynamic process reflects the nature of scientific inquiry, constantly evolving with new information, never fully settled, but progressively more accurate. The Younger Dryas remains a focal point, not only for its own significance, but for what it reveals about climate systems and their potential for rapid change. Understanding this period informs broader knowledge about how systems respond to stress, how thresholds can be crossed unexpectedly, leading to abrupt transitions. This knowledge extends beyond the past, providing context for present conditions and potential future scenarios. In a changing world, despite increasing understanding, some aspects remain unresolved, details that resist clear explanation. Maintaining an element of uncertainty, this uncertainty drives continued research, encouraging new approaches and methods, seeking clarity through persistent effort. Across generations of scientists, the record continues to grow, layer by layer, discovery by discovery, building toward a more complete understanding, even if final answers remain elusive. And within this growing body of knowledge, the story becomes clearer in its structure, if not in every detail. A complex interaction of forces shaping a critical moment. The planet moved through a phase of instability, triggered by factors still under investigation, leading to widespread environmental change and long-lasting consequences. Life responded in varied ways, some adapting successfully, others unable to adjust. Resulting in selective survival, human populations navigated this landscape, adjusting strategies and behaviors, continuing to develop. Within a changing environment, the systems that emerged afterward reflect both loss and adaptation, carrying forward elements of the past, while establishing new patterns. And as research continues, each new finding adds to this evolving narrative, bringing greater clarity while preserving the complexity of the event. As layers continue to accumulate, the picture grows more intricate, not clearer in a simple sense, but richer in detail. Each new dataset adding nuance rather than certainty, revealing how interconnected every system truly is. In deep ocean basins, sediments settle slowly, undisturbed for thousands of years, holding within them microscopic records of temperature, chemistry, and biological activity. These records show gradual transitions interrupted by sharp boundaries, moments where conditions shift more abruptly than expected, indicating external or internal disruptions that alter long-standing patterns. Chemical traces within these sediments fluctuate, reflecting variations in ocean circulation, changes in nutrient availability, and shifts in biological productivity. Some intervals show increased deposition rates, suggesting enhanced erosion on land, carrying more material into the oceans. During periods of environmental instability, others reveal reduced input, indicating calmer conditions, with less disturbance across landscapes and more stable ecosystems. In polar regions, ice continues to preserve atmospheric history, capturing particles carried by global winds, including dust ash and biological material, each telling part of a larger story. Variations in dust concentration provide important signals. Higher levels often linked to drier conditions, lower levels associated with more vegetation cover, indicating shifts in regional climates. These patterns align with changes observed elsewhere, supporting the idea of widespread environmental adjustment, rather than isolated regional events. Connecting distant systems through shared signals, atmospheric circulation plays a key role, redistributing heat and moisture across the planet. Small alterations in these patterns, leading to significant regional differences. Jet stream behavior influences weather systems, affecting storm tracks and seasonal cycles. Shifts in its position or strength can alter climate conditions rapidly. Evidence suggests these systems were highly variable during transitional periods, responding quickly to changes in ocean and land interactions, amplifying initial disturbances. Volcanic activity is also considered, not as a dominant factor, but as a potential contributor to atmospheric composition and short-term cooling. Ash layers found in some regions provide markers for specific eruptions, helping to align timelines across different records. Though not sufficient to explain global patterns alone, solar variability is examined as well. Changes in solar output over time, potentially influencing climate conditions. Though evidence for major shifts remains limited, the combination of these factors creates a complex network of interactions where no single element operates in isolation, but each influences the others. Biological systems respond accordingly. Plant communities adjust to new conditions, expanding or contracting based on climate, altering habitat availability, Animal populations shift in response, following food sources in suitable environments, changing migration patterns, or establishing new territories. Genetic evidence begins to reflect these changes, population bottlenecks appearing in certain species, indicating periods of reduced numbers, followed by recovery in some cases. In humans, similar patterns emerge, genetic diversity showing signs of contraction, suggesting population stress during challenging periods. Cultural evolution reflects adaptation, technologies becoming more efficient, strategies becoming more flexible, allowing survival under varying conditions. Archaeological records show shifts in settlement patterns, sites appearing in new locations, while others are abandoned, indicating movement and reorganization. Resource use becomes more diversified, reducing reliance on single food sources, increasing resilience to environmental fluctuations through broader subsistence strategies. This diversification supports population stability, even as conditions remain variable, providing multiple pathways for survival across different environments. Over time, regional specialization increases, communities adapting uniquely to local conditions, developing distinct cultural identities based on environment and resources. Material culture reflects these differences, tool designs varying across regions, indicating adaptation rather than uniformity. Across human populations, trade networks begin to form more clearly, evidence of materials moving over long distances, suggesting interaction between groups, even without direct contact. These connections allow knowledge transfer, techniques spreading across regions, accelerating adaptation processes. Through shared innovation, climate gradually stabilizes further, though not completely uniform, allowing ecosystems to reach new equilibrium states. Different from those before, sea levels continue to rise steadily, redefining coastlines over long periods, submerging older landscapes, and creating new ecological zones. Marine environments adjust accordingly, species shifting ranges, adapting to new conditions, or disappearing where unable. Freshwater systems respond to these changes, rivers adjusting flow patterns, lakes forming or draining, influencing surrounding ecosystems. Human populations continue to adapt, incorporating new resources, exploring different environments, expanding their presence. Technological innovation persists, driven by necessity and opportunity, each advancement building upon previous knowledge, increasing efficiency and capability. Social organization evolves gradually, groups forming more complex structures, coordination improving, allowing larger communities to function. Information transmission becomes more refined, ensuring knowledge is preserved accurately across generations, reducing loss of critical survival strategies. Over time, these developments accumulate, leading to significant transformation in how humans interact with their environment and with each other. The long-term outcome reflects resilience, not immediate recovery, but gradual adaptation across multiple systems. Environmental conditions continue to influence development, shaping possibilities and limitations, guiding the direction of change. Over extended periods, even as stability increases, variability remains an inherent feature, preventing complete predictability and maintaining adaptive pressure. The memory of past instability persists, embedded within systems and behaviors, influencing responses to future changes. Though not always consciously recognized, research continues to refine understanding, integrating new data with existing frameworks, improving accuracy. While acknowledging complexity, the Younger Dryas remains central to this effort, as a case study in rapid climate change, providing valuable insights into system behavior under stress. Ongoing analysis seeks greater resolution, reducing uncertainty in timing and sequence, clarifying relationships between variables across different datasets. Future discoveries may provide stronger evidence, supporting specific mechanisms or revealing new factors previously unconsidered. Until then, interpretation remains provisional, based on best available data, subject to revision. As knowledge expands, this evolving understanding reflects the nature of inquiry, continuous adjustment, refinement of ideas, and gradual approach toward clarity. The record remains incomplete, but increasingly detailed, allowing more accurate reconstruction of past events. Each contribution adds to this reconstruction, improving coherence while preserving necessary complexity in describing the system, and within this complexity lies the key insight that major transitions rarely result from single causes, but from interactions between multiple dynamic factors. The Younger Dryas exemplifies this principle, a convergence of conditions leading to rapid change and lasting impact. Its study continues to inform broader understanding of climate systems and human adaptation, providing context for interpreting both past and present. As research advances, the narrative becomes more comprehensive, though still open to further refinement. And now, after everything we've moved through, all the layers of ice and water and fire and uncertainty, we arrive not at a final answer, but at something far more honest than that. A moment in history where the world changed faster than anything living within it could fully understand, where entire systems shifted and left behind only fragments for us to study. Maybe it was the sky, a distant fragment of something ancient crossing paths with Earth, breaking apart and leaving behind traces, so small yet so powerful in their effect. Maybe it was the water, silent and patient behind walls of ice, waiting for the moment when pressure overcame structure and reshaped the planet without warning. Or maybe it was neither alone, but a convergence, multiple forces aligning at the exact same point in time, creating a change that no single explanation can fully contain. What remains undeniable is the transformation itself, a world once filled with giants becoming quieter, and a new balance slowly taking shape. The land remembers even when we do not, in layers beneath our feet, in patterns within the climate, in the absence of what once existed. And within that memory, there is something deeper than data, a reminder of how delicate stability can be and how quickly it can shift. Because this was not just a change in temperature or a shift in ecosystems, it was a turning point, a moment where the future separated from the past. The giants disappeared, the landscapes evolved, and humans continued forward, adapting, learning, and expanding, not because they understood what was happening, but because they responded to it moment by moment, decision by decision. And that is perhaps the most important part. Not what caused the change, but what survived it. The ability to adjust, to observe, to continue even when nothing feels certain. That same ability exists now, carried quietly through time, from those distant generations into the present moment. So as this story fades, you are left with the same questions they once faced, not about the past, but about change itself. How it begins, how it spreads, and how life continues within it. You don't need to solve it tonight. You don't need to choose between sky or water or time. You can simply let the mystery exist without forcing it into certainty. Let it drift like sediment, settling slowly, finding its place without effort, because some answers take longer than a lifetime. Some stories are still unfolding, and some questions are meant to remain open. For just a little while longer, the Earth continues its quiet motion, turning beneath the same sky, carrying forward everything that has happened and everything that will come next. And you can let your thoughts slow, let them soften, let them fade into stillness as that distant world grows quiet again, and the questions that shaped it gently disappear into the dark.